Welcome everyone. In this lecture, we will solve a problem based on BJT Small Signal Model and Operation Numerical from Microelectronics circuits book. So the question is in the circuit shown below. So there is a circuit shown below where VB is adjusted to yield a DC collector current of 1 milliampere. So the given thing for the circuit is the DC collector current is 1 milliampere and VCC value for the circuit is already given and I have already put it here 15 volt RC 10 kilo ohm and the current gain beta is equals to 100. So find the voltage gain. So we have to find the voltage gain, say the AB, that is our AC voltage gain VCE by VBE. Okay, AC a small signal gain. Okay, so that we have to first find. Okay, so first of all, before solving this problem, this is a small signal model based problem of a BJT. So before that, first what we have to do, we have to first find the following parameter like GM. Okay, so the GM transconductance of a BJT can be easily found by using the formula GM by GA equals to IC by VT. For this thing, you can follow my earlier video. Okay, so GA IC by VT. So IC is already given 1 milliampere and thermal voltage 25 millivolts. So milli will be cancelled. So 1 by 25. So this will be our simply one can write 1 by 25 ampere per volt or simply 1 by 25 if you write in terms of 40 into if we solve 40 into 10 to the minus 3 ampere volt or better to write simply our 40 millisiemens or simply 40 milli ampere per volt. Okay, so this one is the simple process 1 by 25. Generally transconductance we are writing in terms of milli Siemens or milliampere per volt. So that's why we have written like this because we have to go for the a small signal model. Okay, in hybrid pi model we will draw for this circuit. So the another thing that we required is our r pi. So r pi equals to beta by gm. So beta value will be our given 100 by 40 milli means 10 to the power minus 3. So if this should be cancelled out, then simply we can write 2.5 into 10 to the power 3. So it is nothing but simply 2.5 kilo ohm. So these two parameter we have already calculated because it is very important in a small signal model because we are going for the AC analysis. So the GM and RPI we have calculated. So now we have to go for the AC analysis. Okay, a small signal means the a small v, a small c, a small e, a small v, a small b, a small e. Subscript will be a small b means this is a small signal means AC analysis. Basically we are doing. So for this one, for this transistor, for this transistor, we have to replace this transistor by a hybrid pi model. Okay, so what I am doing, I am just drawing a hybrid pi model for this transistor. So it can be easily made by using in my earlier video I have already mentioned the theory behind it. Okay, so I'm not going to discuss that part. So basically this portion is our base collector and this emitter. Okay, so, and this emitter is grounded. Okay, and this one is our R pi, and this one is our GM VBE, and this RC for the SE analysis. This VCC will be grounded. This VCC will be grounded. So this should be like this. So grounded for the SE analysis. So what I am directly doing. Okay, this should be our RC. Okay, and this should be our VCE. Okay, this should be our VCE. And in addition to that, in this case, for the SE analysis, this VBE, we have to make it short. So simply, okay, this should be plus of our VPE. So that thing we have to find VCE by VBE. Okay, and in this one, this current is our IB, and this current is a IC, and this current will be our simply IE. Okay, simple hybrid pi model we have drawn. Okay, so this current IC means this current, what should be this current IC? So basically this current is our IC. IC. So this one having zero potential and this having VCE. So IC can be written as, the current is flowing like this. Okay, so 0 minus VCE by RC. So VCE value cost minus ICRC. Okay, and IC is nothing but simply GMVPE. So IC is nothing but simply GMVPE So this VCE value is nothing but simply minus GMVPE into RC. Okay, now this one is our simply this voltage in here VBE. So we can easily find the gain, that is our VCE by VBE equals to minus GMRC. We have already solved this concept, but here I am doing directly this one minus GMRC. So this is nothing but simply our gain. So minus GM we have already find out. So minus 40 into 10 to the power minus 3. Okay, and RC is our 2.5 kilo ohm. Okay, so this should be cancel out. 2.5 by 40 means 2.5 into 40. If you multiply, it will 10 10 cancel, 25 into 4. Okay, so minus 40, sorry, minus 40 into RC is our 2.5 kilo ohm. Okay, sorry, RC is our not 2.4, sorry, it should be our 10 kilo ohm. Okay, sorry, this is a mistake. This one is our 10 kilo ohm. Okay, so RC is 10 kilo ohm. Okay, I'm writing here RC is 10 kilo ohm in the question. So it should be simply our minus 400. So the AB, the current gain, will be our simply minus 400 volt by volt, we can say, or unitless. So no need to write, or in sentence means it is writing like it volt by volt, but so, or you can directly write AB equals to minus 400. So this one is the very first thing that we have mentioned, means clear. First we are doing the, what we are doing, first we are drawing the small signal model for a BJT. Okay, then after this part we have remove the VBE. So AC voltage source we have to given RC, then IC we have to find. So this one is grounded, so zero potential, 0 minus VC by RC. Then VB is this voltage. So in the question find. So first we have find. Now the other part. The other part is the, if VB is given. If VB is given, okay, we have to find VCT and IBT. Okay, V small capital C T. Okay, what it means. VCT means the instantaneous. Now the thing is that we have to find V capital CT. It is the instantaneous collector voltage. Instantaneous collector voltage we have to find. So basically this instantaneous means this instantaneous component having some AC component VC, okay, T plus DC component V capital C. Okay, this one is a standard notation I have already discussed in my theory video. Means the instantaneous voltage collector voltage having the sum of the DC component as well as AC component. Okay, so here this one VC is the DC component and this one is our AC component. This one is a AC component and this one is our DC component and this one is the instantaneous one. Okay, so first of all we have to find the DC component, that is our VC. So VC in the circuit, the DC voltage VC can be simply written as VCC minus IC RC, because we know other thing. Okay, means this one is the transistor and this one is our RC and VCC. Okay, it is connected here. Then this VC, the DC component. Okay, I am interested in that part only. So this one is IC. So this VC will be VCC minus ICRC will be this voltage. Okay, so this will be our, okay, VCC is known to us 15 volt. Okay, minus IC is 1 milliampere. So 1 into 10 to the power minus 3 and RC is 10 kilo. Write it 10 kilo. Okay, so 15 minus 10 means 5 volt. 5 volt DC. VC is now calculated. Now we have to find the AC component. Okay, so AC component means VCT. This voltage component, this one is collector voltage. So this VC, okay, this VCT component is nothing but simply this voltage, this AC voltage. So this VCE is nothing but simply minus ICRC, or this one is minus GM So VCT can be our minus ICRC and IC is GM So one can write it minus GM because this one is same. I am just VCE and this one will be same thing. Okay, VC is the minus GM into RC. Okay, so now one can write minus GM value we have already find minus 40 millisiemens. Oh sorry, minus, and GM is 40 into 10 to the power minus 3 VB. Okay, in the question it is very clearly mentioned that a small VBE, the AC voltage, is VB is 0.05 sin omega t. So I am writing here. Okay, this VBE is clearly mentioned 0.005 sin omega t. It is given, means the AC voltage, base emitter junction AC voltage is this one. So simply multiply this one with 0.005 sin omega t into RC. Now RC is already given 10 kilo. Okay, so make it 10 kilo. 10 into 10 to the power 3. So this should be cancel out. Okay, then minus 40 into 0.005. Okay, or it can be solved like this. If you remove the decimal thousand, this should be cancel out 5, then this should be uh, 20, then 10 to 2, 2. Okay, so if you solve, it will come 2 sine omega t with minus sign. The minus sign. So simply we can say, if you solve this one, VCT equals to minus 2 sine omega t. Okay, so the DC component we have find the value of DC component VCT is our 5 volt, and the AC component is VCT minus 2 sine omega t. So the instantaneous one, the this value we can write like this. Okay, the instantaneous one. Okay, V capital C. Okay, this one is capital C. T will be the AC component. AC component like minus 2 sine omega t plus 5. Okay, minus 2 sine omega t plus 5 volt. Okay, it is in the volt. Okay, or you can write like this: 5 minus 2 sine omega t volt. So this one is the answer. Means in our question we have to find the instantaneous voltage. So we have to do like DC voltage. Okay, across the collector we have find easily. Then VCT is nothing but simply collector voltage minus ICRC, and IC is GMVB. The AC collector current is minus GMVB RC. The theory is already mentioned in my earlier video or theory of video, so you can also follow that video for theory. Now in addition to that collector voltage, we have to find the IBT, instantaneous base current. Okay, so that now we will solve. Okay, wait. Instantaneous base current we have to find. Okay, now I will show. That is our I capital B T notation is, you have to clear, means IBT having the AC base current plus DC base current, that we have to know. Okay, instantaneous current. That's why the symbol is I symbol is in the small letter, subscript in the capital letter. Yeah, instantaneous when both subscript as well as symbol AC and both capital, it should be our DC, the standard notation. Okay, now the IB value. The IB value we can easily write like this: IC by beta. IC equals to beta IB. So IB we can easily find. IC is 1 milliampere by 100. Okay. So basically this one is 10 to the power minus 3 into 10 to the power minus 2 ampere. So 10 to the power minus 5 ampere. So basically base current is in the microampere range. So what we can do, 10 by 10 into 10 to the power minus 5 I am writing. So this one is 10 into 10 to the power minus 6 means 10. You can write it 10 microampere will be the base current. The DC component we have already find. Now we have to find for the AC one, that is our IB. So how we can find the IB? So suppose this one is the transistor. So the resistance looking from the base side, that is our R pi, the base, collector, emitter, and some current is going IB, and this value is VBE. So generally we are writing R pi equals to VBE by IB. Very standard thing. So IB can be written as VBE by R pi. Okay. So in my theory it is already derived everything. So one can write VBE by R pi. Okay. So now what we can write? Why we are writing in the VBE? Because VB is already given in the question. So we have to take care, means VB is given 0.005 sine omega t. So that's why I am writing in terms of VB, and R pi we have already calculated in the very first. R pi 2.5 kilo ohm. Okay, R pi to the power 2.5 kilo ohm, beta by GM 2.5 kilo ohm. So 10 to the power 3. Okay, so how we have to solve this one. So one can write this one as a, if you have to solve 0.0052.5, make it 10 to the power minus 3 up sine omega t. How I will solve? If you remove this decimal, how many zero will come? 1, 2, 3. Okay, and if we remove this decimal into 10, okay, so this value 10 to the power 3, 3 will be, and then 5 by 25 means it should be 5, and 5 into 2, 2. So 2 into, we can say this 10 to the minus 6 go up, 10 to the minus 6 sine omega t. Okay, so next how we will write? So this IB value is nothing but simply 2 sine omega t, 10 to the minus 6 is our microampere. Okay, so IB is now our 2 sine omega t. So the DC component, that is our sorry, instantaneous one, IPT will be AC. Okay, AC, that is our 2 sine omega t, 2 sine omega t microamperes, omega t plus DC component 10, and all in microampere, so better to make it microampere. Okay, so this one is the IBT, that is our instantaneous voltage, instantaneous base voltage, instantaneous base current, sorry, instantaneous base current will be 2 sine omega t plus 10. And this one is a problem from the microelectronics circuit book exam, example, exercise problem. Okay, so I have solved, means how we have to do. So but behind that we have to go for some theory. Okay, and this concept we have to know, means how I am writing, why I am writing this formula r pi. Okay, because VPE equals to r pi into IB equals to VBB by VB is given in the question. So like that you can solve this problem. So this is all about this one. But the thing is that you have to very careful about the RPI model. Why I am drawing this diagram, and SE1 SE signal representation means I small, B small, I small, C small, like that everything we can find. So like that you can solve. So that in the question it is very clearly mentioned the VBE and other parameter like this. Okay, so like that you have to proceed, and the voltage gain, this VC by VB first, so we have already find the voltage gain. So this is all about this lecture. So thank you for watching this lecture. Thank you.